Section 2.2 talks about a histogram. A histogram is a graph consisting of bars of equal width drawn adjacent to each other. That's what separates a bar graph from a histogram. A bar graph, there are some spaces between the adjacent bars, but in a histogram, those bars are connected to each other. So wherever one drops off, the other one picks up. The heights of the bars correspond to the frequency value, sometimes to the percentage, sometimes it's up to whatever you are measuring. Horizontal scale. So horizontal scale runs left and right. This is the class quantity data values. Use class boundaries to partition. Remember, we did class boundaries in the last section. Vertical deals with frequency or percentages or, whatever it is you're measuring. And we have an example right here. The price of 30 randomly selected GPS navigators is shown in the following histogram. So here on the left, the frequency. Frequency means how many of those you have. So how many between $58.5 and $114.5, the cost, 5 of them. Between $114.50, $170.50, 8 of them. 6 between 170 and 226, and so on. And that's how you would make a histogram. You notice they're using the class midpoint to connect the two. So, identify the class width. Well, the class width would be what? 142.5 minus, I meant take 114.5 minus 58.5, and that would be 56. So if I look at the classes, remember how we added 0.5 on each side? If I really wanted to figure out what the classes are, the classes would be, the first one will be really 59 to 114, and for the second that will be 115, and if I add, that's 170, and the list goes on, if you recall how that works. So when it says find the first upper classes, the first two upper classes, where they're talking about 114 and 170. That right there. If you remember from last homework, we added 0.5 to each side. That's how we got the class width. Identify the first two class midpoints. To find a class midpoint, well, that's 59 plus 114 divided by 2. That would be 86.5. And 115 plus 170 divided by 2, that is 142.5. Now, I'd like to construct a histogram for the set of, let me see, too big, okay, I'm going to shrink out a bit so I can see the whole thing. There. So, construct a histogram for the data set regarding the inaugural age of the US presidents. Be sure to label the axis and give the histogram a title. Okay, so we're going to go by frequency, and the bottom we're going to label as ages. And if you remember, I'm referring back, I have the paper in front of me. If you remember, we had, let's see, 2, 4, 6, 8, 10, 12, 14, 16, and 18. And make those equal so that the graph will represent the distribution of. So we're going to start with, now, this says we're going to ignore the first interval, and we're going to start with 41.5. Then we're going to run to 47.5 at 6, 53.5 at 6, 59.5, 65.5. So this is from the problem that we did last time. And this is another 5, 71.5, 77.5, and 77, 83.5. So if I look at the first number we had was 6. So if I go to 6, I could make that perfect, but just a rough graph will do. And the next one goes up to 11, so if I'm going to go up 11 about halfway, there we go. And the next one goes up to 17, 17, that's about the highest. Now, you could put the numbers at the top if the graph is like the one I have, unless you have a grid. And then the next one is going to go up to 8. So 8 is right there. And the next one is going to go up to 3, halfway through. Again, these graphs could be done with a ruler and they'll look a lot nicer. Then we have a 0. Then we have a 1. That's a histogram. So a histogram is a bar graph in which the bars are adjacent to each other, or the adjacent bars, I should say, have no gap between them. And this is age of US presidents at inauguration. There we go, got it. Okay, the next page. Well, here we're talking about the distribution. Bell-shaped curve is normal or uninormal distribution. Example, weights, heights, show size, I think it's meant shoe size. Shoe size, standard tests. So a bell-shaped curve, if you look at it, it looks like a bell-shaped curve, really. That's called a normal distribution. It looks like this normally, in general. A double peak or bi-module is something that has 2 peaks. I'll give an example of that. Shoe size of males and females. Uniform, that's when you have the distribution looking alike, kind of like saying roll a die and land on one. Well, you roll a die, the chances of getting each one of those is identical. Scoot to the right, something we're going to focus on, and scoot to the left. Scoot to the right, when the scores on a difficult exam, the majority of the students will score lower as you go up. And scores on an easy exam, majority of the students will score higher. So as you notice from the previous example, each bar represents the number, and you notice the highest bars are toward the 100, and here the highest bars are toward the 0. So stuff like that. Example, for the following data, identify which of the above distributions would you most likely to occur. Again, this is all common sense. A sample of 1,000 home prices in LA County. Well, that's going to be screwed right. A sample of 500 of arrival time at a restaurant that is open for lunch and dinner. That's going to be probably be by module, because the peaks are going to be at both of those. It's going to look something like this. Those are more specific as we do examples, and we will get into full details of those. I was going to do a bar graph here, but a pie graph, but that's might as well. Let's make a pie chart since there is a homework problem on it. So here what we're going to do, we're going to make a pie chart for frequency of the age of the U.S. president's inauguration. So what we do, we get the ages. We make our own table really quick. What we do, we get the age, and that is 42 to 47. So I'm copying what we had, 48 to 53, 54, so you add 6, 60, 66, 72, and 78, and you add 6, 59, 65, 71, 79, and 85. And the frequency, right? We had 6. We had 11, we had 17, we had 46. 46 was the total. 17, we had 8, we had 3, we had 0, and we had 1. So, if I want to figure out the relative frequency, I would divide each of those by the total, and if you remember, the total was 46 presidents. And to figure out the degree on the circle, I would multiply by 360 degrees. I'm going to do that one shot. So if I get my calculator, this is the calculator that hopefully checked out. A TI-84 will do. You really need to do that. So I'm going to run the numbers and I'll copy them later. I'll show you how to do them. Here we are. So if I go ahead and go clear, and if I take 6 divided by 46, 6 divided by 46, I will get, and let me shift my table to 50. Here we go. And what I'll do, I'll multiply that by 360 degrees. And it gives me roughly 47%. Then I go to the next number, which is 11 divided by 46. And that's going to give me the percentage, roughly 23.91%. Multiplied by 360, that will give me the angle, roughly 86.1 degrees. So you get the idea. Now let me close that. And that's how I'm going to do that. I'm going to be showing you how to use the calculator multiple times. So here we got 13.04%. Remember, that's in decimal. When we multiply it together, we roughly got 47 degrees. Here we got 23.91%. Multiplied by 360, we get roughly 86%. 17 takes the highest, 36.96%. When you multiply it out, you get 133 degrees. 8 divided, that's 17.39%. That gives me roughly 63 degrees. and 3 divided will give me 6.52 degrees. That's roughly 20%. This is 0, of course, and 1 divided will give me 2.17%. When I multiply, I roughly get 8 degrees. Now, to put that on a circle, you're gonna do, I'm picking a color that's hard to see. So if I cut this angle, these are 90 each, just for reference. And if I cut that even further, that's 45 degrees each. So I start off with the labeling, and let's start with the blue. 47 degrees. Well, 47 degrees is a bit past that line. Just a bit. Let's say that much. And here we would say this is the 42 to 47. You could label it on it if you want. Same thing. You could just if you could fit it in. 86 degrees. 86 degrees. Well, let's see. That's about 90. So if I run, that's about 90. I took 2 degrees, so that's about 88 degrees. That's good enough. I'll take that, and I'll mark that as the 48 to 53. There. I would take the next one up, 133 degrees. 133 degrees, well, 90 plus 45 is 135 degrees, so that's about all of this. That would be the 54 through 59, and I could label around it just so you could see it. And I could go by the next one and say, well, 63 degrees. That is roughly 45 plus about that much. That is 60 through 65. Again, you could really put it outside if you want. And the remaining, we need 23 degrees. 23 degrees, this is a bit more than that, so about right there. I would say that is the 66 through 71. And lastly, I will point that this is the 78 to 85. And that would be how we make a pie chart.